In this lecture video, we'll be understanding lag, lead, and lag lead compensator. There are three types of compensators which is commonly used, which is lag compensator, lead compensator, and lag lead compensator. So we'll understand all these three in brief in this particular video lecture. So let us first understand what is meant by this lag compensator. The lag compensator is an electrical network which produces a sinusoidal output having the phase lag when a sinusoidal input is applied to it. The lag compensator circuit in S domain is as shown in the figure, in this particular figure. We are having two resistors R1 and R2, and we are having one capacitor which is connected in series with R2. Input voltage Vi of S is applied and output voltage V0 of S is extracted. Here, if we observe clearly, the capacitor is in series with resistor R2 and the output is extracted completely across this particular combination, the series combination of R2 and capacitor. The transfer function of this lag compensator is given by this equation. We already know the definition of transfer function. It is a Laplace transform of output to the Laplace transform of input. So V0 of S divided by Vi of S will give us this equation 1 by alpha into S plus 1 by tau divided by S plus 1 divided by alpha times of tau, where tau is nothing but R2 into C and alpha is nothing but R1 plus R2 R1 plus R2 divided by R2. So this is about lag compensator. Similarly, let us understand what is meant by this lead compensator. A lead compensator is an electrical network which produces a sinusoidal output having phase lead when a sinusoidal input is applied to it. The lead compensator network in S domain is as shown in this particular figure. If we observe in this particular figure, the capacitor is in parallel with the resistor R1 and the output is measured only across R2. There is a major difference between our lag compensator and lead compensator. In the case of lag compensator, resistor R2 was connected in series with capacitor and the output voltage was extracted across this particular combination. Whereas in lead compensator, the output is extracted only across resistor R2 and this capacitor is connected in parallel with resistor R1. The transfer function for this lead compensator is given by the equation beta times of S into tau plus 1 divided by beta times of S into tau plus 1, where tau is nothing but R1 into C and beta is equal to R2 divided by R1 plus R2. So this is about lead compensator. There is one more compensator called as lag lead compensator, or we also call it as lead lag compensator. This lag lead compensator is an electrical network which produces phase lag at one frequency region and phase lead at other frequency region. So it is a combination of both lag compensator as well as lead compensator. So this lag lead compensator circuit in S domain is as shown in this particular figure. If we observe, this lag lead compensator is a combination of both lag compensator network as well as lead compensator network. In lag compensator network, we had resistor R2 connected in series with our capacitor and output voltage was extracted across this particular combination. The same thing is happening even here. R2 is connected in series with capacitor and V0 is extracted across this particular combination. Similarly, in lead compensator, R1 was connected in, capacitor was connected in parallel with R1. The same thing is happening even here. The capacitor is connected in parallel with R1. So our lead lag compensator or lag lead compensator is a combination of both lag compensator network and lead compensator network. So this circuit looks similar to both lag compensator as well as lead compensator, which are cascaded together. So the transfer function of this circuit will be the product of transfer functions of the lag compensating network as well as lead compensating network. I hope that you have understood this video lecture. Thank you.